everybody, it's Mrs. Pound, and I'm back with more from Chapter 4.2 about the oceans. So today we're going to talk about ocean motion. And our objectives today will be to illustrate the parts of a wave, describe how waves are formed and what affects their growth in the deep ocean and close to shore, compare types and behaviors of currents near the shore, and demonstrate the flow of major ocean currents. So first, we need to talk about parts of a wave. What is a wave? So these are the parts of a wave, and there's a big spot in your notes for that. I would like you to copy this diagram down, and then we will talk about each of the different parts. So the trough is the lowest point of a wave, and it's right here. And this is your typical transverse wave like we've talked about in physical science. So you should be pretty familiar with this. The wavelength is the distance between wave crest here. The wave height is the vertical distance between a wave crest and a wave trough. So this whole distance from a crest to a trough is the wave height. And we also sometimes talk about the amplitude. This is a wave's height or depth measured from the surrounding water level. So we can see here the amplitude is labeled and it's half of a wave height. So now that we know the parts of a wave, let's talk about different types of waves we find in the ocean. And what we have to understand about waves is that waves become larger and smaller due to changes in wind speed. So most waves are due to wind speed. There are a few exceptions that we'll talk about. So the first type of wave I want to talk about are those just little ripples in the water from a gentle wind, and we call these capillary waves. Think of them kind of like the capillaries in your body. Those are the smallest blood vessels in your body, and so these capillary waves are the smallest waves in the ocean. There are also the largest waves would be, well, not quite the largest, but pretty big, strong waves would be whitecaps. These are waves formed by high-speed winds whose crests have been blown off. So you don't want to be in the ocean when these are happening because this is generally during a storm and really high winds. There are also special waves called tsunamis. These are a very large ocean wave caused by an earthquake or volcanic eruption. And these can be really powerful. These can be really tall, just tens of meters tall, 10 meters, I believe even 30 meters tall. And they are not caused by winds, but by earthquakes and volcanic eruptions. There are also, closer to shore, there are waves called breakers. This is a toppling wave close to shore. What happens is the wave approaches shore. The bottom of the water, due to friction, slows down, but the top of the water is still going faster, and due to inertia, it falls over itself. Because we have slower, faster, it goes over and falls over itself. So those are called breakers. Those are not whitecaps. Now, in the ocean, another type of motion are currents. And these are rivers in the ocean, and these were actually described in the Bible before they were discovered. And the gentleman who discovered them actually read about them in the Bible, and he went looking for them because he read that there were rivers in the oceans in the Bible. So he went looking for them, and surprise, he found them. So a current is the continuous flow of water in a certain direction. One type of current is called an undertow. This is the rapid flow of water back to the ocean after a wave breaks on the shore. And I'm sure if you've ever been to the ocean, you have felt the undertow because you get pushed by the wave and then there's that rush of water backwards that you feel like it's going to sweep you out from under your feet and you are going to go back to the ocean with it. Now, these are usually not very strong currents, so you don't really have to worry about it taking you out very far in the ocean, but it will pull things like seashells and everything out, but it will not take them all the way out to sea. The current you have to watch for on the shore are rip currents. This is a strong, narrow current flowing away from the shore toward deeper water. These can be very dangerous. These can take you quite a ways out into the ocean. Rip currents form near structures or where there's a shallow trench actually in the sand. And as you can see here, they will take you out into the ocean in this diagram. The best way to escape a rip current is to swim, as you can see the swimmer in the diagram, swim parallel to the land until you can get out of the current. But these are the currents you do have to watch for that can, in fact, be dangerous. There are also surface currents in the ocean. These are driven by the wind. Their direction is affected by both wind direction and the Coriolis effect. And they affect ocean temperatures near the surface and land temperatures near them. So we'll talk about the Coriolis effect here in a few minutes. As far as affecting land temperatures, there is a current called the Gulf Stream in the Atlantic Ocean that takes in the northern part of it, it takes warm water over towards Europe. And because it is a flow of warm water towards Europe, the winds blowing off the ocean actually cause European countries to be warmer than they should be for their latitude. Now, it does not, it also goes up the edge of the United States, but it doesn't really affect the land temperatures there so much because wind there blows from, just like in Europe, from west to east. And because the wind is blowing away from the land, it has less of an effect on North America. And I also want you to go ahead and get out your earth science reference tables on page 4 because I want you to take a look at those and I want you to take a look at the Coriolis effect. This is the curving of moving objects from a straight path because of the Earth's rotation. And what you'll notice in your earth science reference tables is that in the northern hemisphere, the currents go clockwise, okay, for the most part. And in the southern hemisphere, they go counterclockwise. This is due to the Coriolis effect. And this is not a current here, this is actually a hurricane. The Coriolis effect also affects hurricanes, which we will talk about when we talk about weather. So here's the page in your reference tables, surface ocean currents that I was talking about. It's page 4 right there. And what we can see is that the key shows warm currents are the solid black lines, cool currents are the white lines. And like I was saying, here in the northern hemisphere, for the most part, now there are a few exceptions, but for the most part, the currents are flowing clockwise due to the Coriolis effect. And in the southern hemisphere, for the most part, other than a few exceptions, they are flowing counterclockwise, the major surface currents. Now, no, these are not all the surface currents in the ocean, but these are the major ones. And this is that Gulf Stream current that I was talking about that takes all of that warm air into Europe because of the warm water, and then the wind blowing over the warm water makes it warmer in Europe, where it's not as affected here because our wind comes from the west, and so it's blowing out to the ocean. If you are listening to this video, I would like you to draw a cloud blowing like the wind next to surface currents to remind you that they are driven by the wind partially. So draw a cloud with wind coming out of it, like it's blowing wind. And then the last thing we're going to talk about are these deep currents. And they are driven by changes in water salinity and temperature, and they cycle nutrients through the various oceans. And so I have a diagram of that down here. And what we see is that these ocean currents, the blue are cold, the red are warm. It starts up by Greenland, and this actually sinks and circulates, and that water goes over to the Pacific Ocean and the Indian Ocean, and it starts to warm and rise and then cycles back actually all the way to where it started. And so it goes all over the globe, and it's called the Great Ocean Conveyor Belt. It's actually really slow. It takes about 1,000 years for the water to actually completely circulate, but it is circulating even in the very depths of the ocean. So our objectives for today's video were to illustrate the parts of a wave, describe how waves are formed and what affects their growth in the deep ocean and close to shore, and compare types and behaviors of currents near the shore, and demonstrate the flow of major ocean currents. So don't forget your 5 questions, and I will be back with more about the oceans.